Hello, my name is Rob Reynolds. Welcome to Business Calculus, Chapter 5, Section 6, our last section in Chapter 5. Today we're going to be learning how to find estimations of sums of area underneath the curves. So it's called Riemann sums, and we're not going to do the left or the right, but we're going to focus in on the midpoint formula, although there are different formulas, and you'll need to know these formulas. This stands for the width of each rectangle. I'll explain that. And then this symbol is sigma, and it stands for the sum of all the rectangles. So this guy is the width, and this guy is the height. And you know that each rectangle is, the area of each rectangle is its width times height, or length times width. So this is a nice definition, but I don't think you'll need to use it because we're just going to count the rectangles. But I just wanted to show you there is a formula for this. So what's happening, there's something called the midpoint rule, which we're going to be using. So we're not going to be using, here's the left. You can see these green triangles are the left areas, and then these are the rights. See how the right side of the triangle falls on here's the function, here's f at x, so the right side of the function. So we're not going to do left or right because, well, oftentimes the left is an over or underestimation, and the right is an over and underestimation. Instead, we're going to be using these midpoints, which makes it actually a little bit more difficult because we got to find these numbers in between. So we have to find out how many rectangles there are. That has to do with this delta x, the width of each rectangle, and then we need to find these midpoint numbers, which is of course halfway in between. So we're going to be using this midpoint rule, and let me show you how to do this with an example. So again, if you haven't gone to Blackboard and copied off the worksheet there, I would encourage you to do that. So it's going to give you n equals 5, and that just means there needs to be 5 rectangles. So 1, 2, 3, 4, 5. And what I like to do is just put this on a number line first of all. So I would encourage you to go between 0 and 2. That's the total area underneath the curve that we're going to be finding. And then we're going to try to break this up into 5 units. And to do that, we're going to use this formula to find out the width of each. So instead of worrying about where this goes, we'll find out, well, we know if we're breaking this up into fifths, we need 4 lines. So I'm going to go 1, 2, 3. So let's see, 1, 2, 3, 4. Well, that's wrong. So let's not do that. So I need 1, 2, 3, 4. 1, 2, 3, 4 to give you 1, 2, 3, 4, 5. So the first thing I would always suggest doing is finding delta x, the width. And so we have everything we need right here and here. So it's b. When you integrate this thing, it's going to be integral from a to b of the function. So a to b, they're telling you, is from x to low to high, 0 to 2 of negative x squared plus 5. And so if you punch this in the calculator, which we're going to learn how to do, you'll find the exact area. But remember, we're not finding the exact area. We're doing approximations. So don't use your calculator just to type that in, but we'll do that later in this video as well. So the first thing we want to do is find delta x. So this is kind of my a term. This is my b term. So I'll do 2 minus 0 over 5 and find out that the width is 2/5. So it's easy when it starts at 0 because you just add 0 plus 2/5 and is this tick mark. So 2/5 and then add 2 more fifths, which is 4/5, 6/5, 8/5, and then of course 10/5, which we've already written as a 2. But you're not interested in that. You're interested in these little midpoint green dots because we're going to go for these green dots, the midpoints. And the midpoint is add these up and divide by 2. It's the average. So halfway between is 1/5. And then all you have to do is add delta x to 1/5. So because that's this distance between these dots is still delta x. So 1/5 and 2/5 is 3/5. 5/5. I'll write 5/5, but it's really a 1. 5/5, 7/5, and then 9/5. So we've done a lot of the hard work. In fact, that's this part right here. So that's a visual of the midpoints. So now we're going to find the height. So that's why I gave you this formula. The total area is the sum of each height. And the height I'm going to call f of x star. And then I'm going to multiply that by delta x. And since delta x is a constant, I can just pop that constant out front. The reason why I use x star is because it keeps changing. So this guy is the height right here. And to find that height right there, I do f of 1/5. And then to find, of course, this height, I just do f of 1. So I'm going to find the height of each one. So the area is, this stands for the sum. That's your sigma. The sum of, so I have this delta x, which I'll pop out front. That's my 2/5 times f of 1/5 plus f of 3/5 plus f of 1, 5/5, plus f of 7/5 plus f of 9/5. So then I simply just go to the function and evaluate f at 1/5. And f at 1/5 is 125/25. The easiest way to find that is to go to your calculator and type in under your function your y sub 1, like you're going to be graphing this. And then we're going to make sure that our window, our table setup is at ask. And then I'm just going to go to my table and actually ask it to evaluate at 1/5. Now, if you type in 1/5 like this, you're going to get the decimal. But if you type in alpha y equals and change that to 1 divided by 5, then you get the, well, found a mistake. So this is really 124. Glad I didn't go much further. 124/5 plus. All right, let's keep going. Let's plug in the 3/5. So again, alpha y equals, type in this fraction, 3/5. The decimal's not bad. Oops, didn't do that right. Oh, let's try that again. 3/5, very hard to do on this. 116/25. Since I'm here, I'll just keep going. Oh, gee, many crikeys. Didn't even need to do that. 1 divided by 1. I should have just done a 1. 7/5. Well, you get the gist. You could finish this out. So here I've finished that out for you, and then I just take my calculator and number crunch this. Remember, this is just an estimation. Here's how the author worked it out. This is just an estimation for the area underneath the curve. To find the exact area underneath the curve, this is an estimation, this 7.36. To find the exact area underneath the curve, we can go back to our calculator. There's 2 ways that I'll show you. We've already got the function in here, and I'll hit second calculate number 7. I'll just hit the white key 7. You can scroll down to 7 if you want. And then the lower limit was 0. The upper limit was 2 because we were integrating from 0 to 2, and it fills this in, and you can see 7.333 is the exact area. And so we're close with our approximation. Another way to find the exact area, which I like better, is to get out of the graphing mode and hit Math 9. And that just brings it. We're going to integrate this from 0 to 2. And then here's where I type in the function, that negative x squared plus 5. And then I have to type in the x value here for dx. And it gives me the same thing. And I kind of like this because this is a nice visual. And here's the author's exact. We could have done this by hand and evaluated it using our integration rules. They didn't ask us to do that, we could use a calculator to do it as well. Let's try another example where I'm still going to be using delta x and the midpoints to do this formula. Again, you can use that sigma, that's shorthand of f of x star times that delta x, which I always like to just pop out instead of multiplying each, because the width of each is the same, so you could just factor out the width. So this is just saying if you have more rectangles, here's 15, 20, you can see I'm getting closer and closer. So the more rectangles obviously you have, we only had 5 in our example, but the more rectangles, the more accurate you would get. And so eventually we're going to be pushing the number of rectangles to infinity to get the exact area. Let's try example 2, where it does not start at 0, and this makes it a little bit harder. Oh, this one does start at 0. So 0, we're going to find the area between 0 and 1. I think perhaps my third example does not start at 0, and that adds another level of difficulty. So let's go find delta x by doing, here's my a term, here's my b term. So b minus a over n is, again, is 5, and this time it's 1/5. So again, this is a 1/5, this is 2/5, 3/5, 4/5, and of course 5/5 is the 1. But I want to find these red midpoints. So this time the midpoints are halfway between, which is what? Midpoints 1/10, 3/10, 5/10. This one is going to be, you see the patterns here, 7/10, 9/10. So I am going to be doing the area is going to be delta x times f of, I'll just say x star, because sometimes x star is the first one, the second one, the third one, and so on and so forth. So the area, in this case, delta x is 1/5. 1/5, and then I'll go to my calculator again. I'll type in the function under my y equals, and then under second graph I'll type in the 1/10, 3/10, 5/10, 7/10, and those go here. So this 100 divided by 101, I think the author writes that a little bit differently. I don't really know why, but that's the same thing as 1 over 1.01. I don't know why 1 divided by 1.01 as a fraction. It's the same. Or you could just do the decimal, but see, it's hard to do the decimal because it's 0.9900. So you don't want to round that until the very end. So we continue adding all these up and then estimate the area. So again, finding the height, finding all of the, here's their heights, this is the width, and here's the estimate. The actual area is this. It's again close, but not exact. Example number 3 is the example that I was showing you that does not start at 0, and it makes it a little bit more complicated. Let's go find delta x, which is, here's my a, here's my b term. So 3 minus 1 over, do I still have 5? Sometimes, nope, this time there's 10. Rectangles, well obviously there's 10. I can see them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 2/5, or this time the width is 1/5. So this next line, or right here, is going to be, I'll just bring it down here, 1 plus 1/5, which we will probably do better to call that 6/5. So my line does this from 1 to 3. This is a 6/5. So once I find that guy, all I need to do is add another 1/5 to that to find the next point. So that's easy. 7/5, 8/5, 9/5, Jiminy Crikeys, 10/5, and then continue doing this. Obviously I need to scrunch down my line, so I'll just do a break and do it all the way up to 15/5. So you can see I've got several more tick marks in there. But what I wanted to show you was we're doing the midpoint rule. So we actually need to find this guy. So I would add the 1 plus 6/5 and then divide that by 2 to find the midpoint. So that's really 6/6. So 12/5 divided by 2 is like multiplying by a half. Wait a minute, what am I doing? This is not 6/6, it's, oh good lord. Let's try 5/5 because I need common denominators. So then this is an 11, sorry about that, times 1/2, and then there's my first midpoint is 11/10. So again, that was a lot of work, but all I have to do once I find that first midpoint, so I have the area equals delta x times f of, these x stars keep changing. Well, the width was the 1/5, and then I'm going to do f of the first x star is 11/10, and then all I have to do is add 11/10 plus the next width, which was 1/5, but I'll write it as 2/10. So just keep adding 2. So it's going to be 13/10 plus f of 15/10 plus f of 17/10 all the way to f of, and it's not 3, because this last one is really 30/10, and you're doing the midpoint, so we're backing that up, so it's really 29/10 is what we're going to go to. So that's going to take a little while to type into the calculator. There it is. There's all the lists of all of them. We'll remember, go to the function because it's f of 11/10. So actually go to your calculator and calculate those. Of course, I would use your table setup. I wouldn't write this statement. And see if you don't get the 4.504. Remember, if you're going to write down and record decimals, you don't want to record 3 decimal places. You'll want to go out 4 or 5 decimal places because if the directions say round to the nearest 3 decimals, you need to know what that digit is, so to be accurate enough. Or you could type this in and just don't round. So there's no reason why your calculator can't swallow that up and spit out the correct answer. But if you're going to record this pink guy as a decimal, just be careful. If you round that decimal to 3 places, then you can't give a final answer of 3 places. If you were to use integration skills and actually integrate this, you can actually find out algebraically, but you could also use your calculator by, again, choosing math and then 9. It's a nice little setup. We're going to integrate from 1 to 3. The function, you guys are better at technology than I am. Second square root of my x squared plus 1, and then tell it dx. I wish it would just default to dx. And 4.50, here's the exact. See how that 8 rounds that 4 up. So our estimate was very close. So the rest of this is just kind of some more explanations. I just want to tell you that if we could push this to infinity, which is what our calculator does, we find the exact area. I've already shown you how to use this. It says midpoint program rule. I think that just means use your calculator. And so I've already shown you how to do that. But don't do, well, you can if you want to see a visual of the graph. But again, I would choose Math 9. So see if you can't type this in, integrate it between 0 and 1 using your graphing calculator. And again, there's ways to do this by, it's complicated, and I don't think I'm going to ask you for the approximations of 10, 20. If they do, I'll go make another video and post it. But there's a way to put the upper limit, the number of divisions, and then get an approximation really quickly. But I think I don't think that they'll either ask for n to be 10 or they'll ask n to be 20. If they get up and n is even 20, I don't want to sit there and add 20 numbers. So there is a way to do this approximations on the calculator, but again, I don't think that they'll go past n equals 5 or 6. I just did a 10 one for you, which seems a little bit ridiculous. If there's more than one, n equals 10 or higher, shoot me an email and I'll make another video showing you how to do that. But really, honestly, if they asked for 10, it's look at this. By the time you get to 20, it's so close to the exact. So these estimates are pretty good. Here's the exact answer, and make sure that you can do that with your graphing calculator. If you have any questions, feel free to email me. Thanks.